Hey guys, we're working on the Unit 4.2, which is our last test of the year review sheet. I did circle all the questions that you do need to complete. I'm going to give you a few hints on some of them, and I'm going to do a few of them with you. Okay, the first one I'm going to take on is number 2. Find the area of each regular polygon, include the appropriate units, show your work, round your answers to the nearest hundredth. So we're given this shape, so we need to find the area of this polygon. I'm going to give myself some room to work here. Okay, well the first thing we know we're given is we have the apothem here, which is 2 inches. But we do need the central angle. So I'm going to take 360 and divide by the number of sides, which is 1, 2, 3, 4, 5, since it's a pentagon. It's going to give me 72 degrees. Okay. Step 2 on your direction says draw the right triangle. Okay, on the polygon and next to the polygon. Okay, so I do that. But remember that 72 degrees is the whole central angle. We're only going to use half of that, which is 36 degrees. Okay, and then we're also given this 2 inch, which is the height of that right triangle. Step 3 says use SOHCAHTOA to solve for the missing side lengths. So we don't know the opposite right here. We don't know the hypotenuse, and we do know the adjacent. But remember, we don't necessarily need the hypotenuse. All we need is the opposite side. So step 3, we're going to use SOHCAHTOA to solve for the opposite side. Well, I know the adjacent, and I'm solving for the opposite. So which trig function uses O and A? It's going to be tangent. So tangent of the angle, which is 36, is equal to the opposite side over the adjacent side, which is 2. Plug tangent of 36 in your calculator. You get 0.7265. Multiply both sides by 2, so the 2's simplify out, and that opposite side is 1.453. Okay, so that opposite side is 1.53, but remember that the whole side length is actually going to be 2 times that. Okay, so let me get a little more space over here. So that whole side length right there, this is 1.453, but I want this whole side, so I have to multiply by 2, which is going to give me 2.906. And that's the side length I'm going to use in my formula. And it says find the area. Well, area equals 1/2 times the number of sides, which is a pentagon, so 5, times the side length, which we just calculated is 2.906, and the apothem, which we were given, which is 2. Plug that all in the calculator, and you get 14.53. We're talking about area, so it's inches squared. Okay? Next, for number 5, find the area of an octagon with apothem 6 centimeters. Okay, so you can draw the octagon here. We're given the apothem already, which is 6 centimeters, and you know the number of sides, which are 8. So to follow the exact same steps, solve for the central angle, use SOHCAHTOA to find the opposite side, but now instead of a pentagon, we have an octagon with a 6 centimeter apothem instead of 2 centimeters. Question 7 and 8. I'm not going to take on question 7, because you just got to find which formula it is on your purple sheet, and then plug in that radius, but I am going to try question 8. So the formula for a volume of a pyramid is 1/3 if it's a square base, and it's going to be length times width times height. Okay, now we have our length, which is 11. These congruent marks means that it's a square base, so that means the width is 11 inches, but we do not have the height. Okay, so the height is perpendicular to that base. Okay, so we need to figure this out. So what you're going to see is, if I draw this right triangle separately, we don't know this height. We do know that 12 inches is the hypotenuse. We need to figure out the other side. Well, if the whole thing is 11, then this side of the triangle is going to be half that. So it's actually going to be 5.5. Okay, so it's going to be half the 11 inches. Okay, so now we can use a squared plus b squared equals c squared, a little Pythagorean theorem. 5.5 squared plus the height squared, which we don't know, equals 12 squared. Solve for h squared. If you do so, you get 113.75. square root both sides, and the height equals 10.67. So now we have 10.67. So now we can go back here and plug in. We have our length and our width. So it's 1/3 length times width times height. And then we can multiply all that together. And we do get 430.36. And it's talking about volume, which is inches cubed. Okay. The back side. I'm actually not going to do any of these questions, but I'm going to help you set them up because I think you guys are more than capable of taking them on. Number 10. We have a prism with a length, a width, and a height with another prism that is subtracted out. So you need to find the volume of the big prism and subtract out the volume of the little prism. So what we need to do is we need to find the volume of the big one, which we have the length, the width, and the height. But now we need to figure out the volume of the little prism. Well, it shows us the length, which is 2 meters, and the width, which is 2 millimeters. But what about this height right here? Well, it's actually the same height as the big prism. So it has another height of 3 meters. So please use that with the idea that it's going to be subtraction to figure out the remaining volume. Okay. Question 11. The only hints I'm going to give you is this is that ratio. Remember, the side ratio is going to be side to side. The perimeter is going to be side to side. The area is going to be side squared to side squared. And the volume is going to be side cubed to side cubed. So use that information to see if you can figure out number 11. Number 13, give 2 examples of how a 2-dimensional shape could be rotated to form a solid. I'll do one of them just to show you what it looks like. So if I take a rectangle and I rotate it 360 degrees, that's going to create a 3-dimensional shape that is a cylinder. Okay, rotate this rectangle around and you have the cylinder. There's one example. See if you can find another. Question 14. A cone has a diameter of 20 centimeters. Okay, and its height is 52 centimeters. You need to calculate the volume first, which you can do now that you have the picture, and then take that volume, which is in centimeters cubed, and find the density, given this conversion, which is just like the huge word problem that we did in class together. And lastly, 22, 23, 24, there will be constructions on this test, but remember, you can use your construction notes. Okay, so take a look for that yellow sheet, see if you have it. If not, please print another copy off of Schoology.